Hello, everybody. Welcome to our 5G panel discussion today. My name is Sherry Willey. I'm part of the Telematics product management team at Qualcomm, and I've been working in the telematics industry for the last 14 years. I'm joined today by three panelists. First, I'm joined by Hajong Sang, who comes to us from LG Electronics. He is leading the 5G telematics platform for LG. He comes to us with 20 years of experience from LG and has been focusing on telematics for the last several years. Second, we have Norbert Muhrer, who is the president and CSO of Quectel Wireless Solutions. He's been in the IoT industry since 2006, and he's joining us from Germany. And our third panelist is Siva Virapalli, who is the VP of Engineering at Qualcomm. He's been in the industry since 1996, and he's currently leading our telematics platform engineering team. So please extend a warm welcome to the panelists today, and we can get started. So I'd like to start this discussion with us thinking a little bit about how 5G as a technology will come in and will change the way that the vehicles operate with each other. So this is a question for Norbert. My question for you is, how do you see 5G will change the way that vehicles communicate with each other and traffic systems around them?
All right, so thanks, Sherry, and also thanks to Qualcomm for inviting me out to this panel. Very appreciated. So on your questions, I think the vehicle is undergoing a massive transformation, which it used to be a lot of steel on wheels, and it's becoming a multimedia infotainment, always on connected platform, delivering various colorful services to the user, delivering all kinds of telematics services and infotainment services to the vehicle company, and now gradually and more connecting with its surroundings via cellular V2X, enhancing this way the autonomous driving behavior. So actually, I tend to think that we're not talking so much about a car anymore in its classical sense. It's more a smartphone with wheels.
Interesting. Yes, I agree. You know, I see that there is more and more technology in the car, and even to a point where drivers tend to pick the car for its technology and less so for, you know, the power of its engine or something along those lines. My next question is for Siva. Siva, my question for you is maybe more on the technology perspective. How do you see that 5G might improve the safety in the car and the way that people use their cars?
Thanks for the question, Sherry. I think 5G has numerous enhancements on top of 4G. I think we all know that 5G provides very high data rates and high spectral efficiency. But 5G also provides very high reliability, ultra low latency. And there are other complementary technologies like small cells, massive MIMO, beamforming, relay capabilities, sidelink capabilities, all of which allow you to deploy a much more ubiquitous network. So if you combine high reliability, low latency, high data rates, and ubiquitous networks, what you have is all the ingredients that allow you to deploy safety services on 5G, and not just basic safety services, but advanced safety services that allow you to, for example, transfer sensor information and camera feeds and high definition videos to first responders or to another vehicle so that it can act on it. As you can see, there's 5G has the potential to offer many safety services. But here, since we're talking about this in the context of automotive and telematics, I think I have to mention two main features that are specified in 3GPP. One is NRV2X, and the other is NG eCall, right? So with NRV2X or cellular V2X, you're able to transfer information from receive information from other vehicles, from infrastructure, from pedestrians, and allows you to make the vehicle a lot safer. Combine that with, for example, compute intelligence inside the vehicle, for example, autonomous vehicle, which has information that it is receiving from sensors that it can see around the car. You bring in another sensor like an RV2X into the vehicle that provides sensor information, intention sharing from another vehicle that's out of line of sight from the autonomous vehicle, then you have a really powerful safety sensor inside the vehicle that allows you to make the car a lot safer. And then, finally with NG eCall, really NG eCall is next generation eCall, which is eCall offered over a packet switch network like 4G or 5G. And there you're able to transfer things like MSD, for example, to the public safety access point or the PSAP on a packet switch connection or an IP connection a lot more reliably. And you're also able to send things like camera feeds, like the dash camera information, or convert speech to text and send it from the vehicle to the PSAP, or even control the car remotely from the PSAP, like turn on the light, blinkers on or off, or lock and unlock the doors. So there's a lot that you can do, and it's still the same eCall. You still get this the voice call, but as you go from 3G to 4G to 5G, you're able to add this additional rich data that goes with the voice call and allows you to offer much more safer services in the car.
All right, thanks, Siva. There's obviously a lot of new technologies that are coming in with 5G. And given that Hajong here from LG is working on the platform integration in the vehicle, Hajong, I would be interested to hear your perspective on how the evolution to 5G is changing how the telematics system is integrated into the vehicle. If you can talk to us if you see any trends or ways that systems have changed since we were looking at 2G and 3G and 4G platforms.
Actually, I'm currently interested in the DSDA feature, which is the key factor in the 5G telematics platform. Actually, the DSDA, that is the dual SIM directive, is required for the 5G connected cars to provide a separate 5G communication service to drivers. And this enables drivers to enjoy all the mobile services in a car while sharing data plans with their smartphone. That means that the users don't need to pay the additional pay. And these services are provided seamlessly when they get on the car without any additional efforts for connection. And also the quality of mobile communication can be improved by using the telematics module with the external antennas that have higher gain than the smartphone antennas has. Also, from the car OEM perspective, the mobile data for OEM specific and safety services is not mixed with the user data. And this means that the more stable and secure mobile services are allowed. So I think that the more and more the premium OEMs requires the DSDA features, And DSDA is the key factor for the premium cars. And this is the new trend.
Mm-hmm. Okay, yeah, DSDA is certainly a very interesting technology. It's also quite interesting in terms of, as you mentioned, the separation of services that the OEM can offer and services that the consumer can use. Norbert, I have a question for you as a follow-up related to this. How do you see new business cases opening up for these kinds of services that can bring value to either the car maker or to the consumer when we have these advanced technologies in the car?
Yeah, I think when we take a step back and let's look where's the money, right? Who is paying for what? So I think we have three economic drivers in the industry at current. So let's start with the vehicle itself, and because everybody, the premium OEMs, they want to lead the pack, come out with something different each year. And now actually we would be in CES times, right, when we would see all the new automotive innovations live, which unfortunately is not happening. But we can see, and I think it's proper that to say that vehicles innovations are not determined any longer by more horsepower and more speed and more tonnage, but they are now determined by assisted driving. How ready is the vehicle to connect to its environment? How ready is the vehicle to collect to multimedia services? And what Haiyong said also, does it actually offer the user its user experience that they are used? If they open their laptop or their tablet, they want colorful services. And so the OEMs are one driver for that, right? The second driver, and that's also where a lot of money is, with the new connected vehicles, and 5G is enabling that, is the amount of data rates that are coming out and going into those vehicles, right? And if you see, in the beginning of my career, we connected a BMW with a 2G modem, right? And we were happy to have some telematic data, window wipers on, off, headlights on, off, and the passenger could do a voice call. So we talked about kilobytes of services out of the car today. If you take one of the modern e-vehicles, and there's a couple around the world of those, these guys are doing gigabytes of data each month, right? So now you think about a mobile network operator, right? How much new traffic and new revenue dollars are coming out of a vehicle today than they used to 10 years ago. So the second driver, mobile network operators. And last but not least, I think it's the driver. And at the end, I'd say even a driver community, right? So purchasing decisions today are more and more going with following ecological principles. The world is getting greener, and that's more and more getting into the heads of everybody. And we see global pollution, and a definite step to counter that is electric vehicles that are all made for autonomous driving and 5G connectivity, so that they're all up to speed. So purchasing decisions are going this way. And if you enter a typical new electric vehicle, the first thing you will find is an immense large tablet. And I do remember a friend of mine, he lives in the US, and he was driving to work, and he had his car self-driving on I-95, and we did a video conference in parallel. We had it's an enormous experience, right? And everybody likes it, including the mobile operator, because they are clocking big revenue streams. So it's so impressive. And my last issue now is not only the driver, but let's say a collective of individual drivers. So another trend that's happening is the urbanization, right? People are moving to the cities for better job opportunities, for better lifestyles, which means cities are getting clogged more and more. And us being a Chinese company, I would say we can sing a song about that, right? How packed those mega cities are. You can, in Singapore, the parking spot is more expensive than the car. In Hong Kong, the same. So drivers, and we did a poll through the young generation. We asked a couple of thousand people less than 30 years old, what form of transportation do you want to have? And say, I live in the city. I'm happy with some form of light urban mobility, like a scooter. And in terms of a car, I want to use a car when I want to, and I don't want to own it and pay for it while I don't need it, right? So there will be, I think, other than the car going 5G and be always connected, it will also become part of our sharing economy, right? So
yeah,
it's important from various aspects.
Yeah, and I think also with the connected vehicle and people, and like Norbert said, you know, you have this nice flashy screen when you enter the car, and there's so many applications that customers can use. Tying it with what Hajang said about DSDA, the consumer has the ability to bring in their own SIM into the vehicle, their own subscription into the vehicle, and use the applications of their choice with the connectivity that is much more reliable, because now you have the antenna on the car instead of inside, you know, the vehicle, the device inside the vehicle. That really also enhances the experience for the customer with DSDA and the additional compute capabilities within the car.
Sure. Yeah, there's certainly a lot of changes that are being derived from the introduction of 5G. I'm hoping we can talk a little bit more about the experience inside the car. Norbert gave us a great example of you know, doing the video conference while commuting. Question for Hajang. I'm hoping you can add your perspective on this, on how you think that user experiences will change or new experiences might emerge with the higher data rates for the experience inside the car specifically.
Okay, so from our perspective, that actually from the data, I mean actually the 5G doesn't have the special the technology compared to 4G, but I would like to focus on the latency. So maybe the higher data speed in the 5G delivers the drivers the real-time traffic information, and maps also allows the passengers to enjoy the crowd service entertainment, such as the real-time gaming and maybe high-definition videos. But especially the real-time gaming or the VR, AR, or VTX, that really requires the low latency, which can be enabled by the 5G network slicing technology that allows latency sensitivity traffic. So to enable this technology, that maybe the 5G SA network should be deployed, and so there are some more the advanced technology that is maybe edge computing should be also introduced to enable this low latency. So actually, the most of people are saying that the 5G data rate is higher than the 4G. Maybe I agree with the most of the person's opinion, but I would like to focus on the key features, that is the low latency. This low latency really enables the various the new experience, the services.
Yeah, no, that's an important point, that certainly it's not just data rate, but also latency. One of the other factors that is shifting in 5G, or there's new technology in 5G, is around the security. And Siva, I'm hoping you can add some perspective on how 5G technology brings new aspects with respect to security in the car. Could you take us through that?
I think 5G is going to be like a critical infrastructure in the future, right? I mean, with support for private networks, public networks, safety, healthcare, industrial, transportation. So you can see that it opens up numerous opportunities, and of course, it brings with it numerous challenges. And as you can imagine, the threat surface increases quite significantly with so many sectors being addressed through 5G. When 3G and 4G networks, or 2G and 3G networks were being designed, security was not the focus of the design. I'm not saying that 2G and 3G networks don't have security, but it was not central. It was most of the time an afterthought or an add-on. With 5G, because of the criticality and the importance of security, most of the design of the devices, the RAN, the core network, and all the interconnecting fabric between these various networks is being designed with security as a central part of the user plane design, of the control plane design, the management plane design. So that's, that really improves the security of the network. If you look at CV2X, devices exchange critical information that determines the safety of the occupants of the vehicle or the people on the road. And so it's absolutely critical that the vehicle trusts the information that it receives. Every message that's sent over the PC5 link is encrypted, signed using a digital certificate, 384-bit keys or 256-bit keys. And there's also a root of trust, which allows the device to trust the message that's received, that it's being received from not from a fraudulent user, it's from a trusted user, and is able to validate the message. Similarly in 5G, WAN connectivity, as you're transmitting data from the device to the core network, to the RAN, to the core network, this data is being sent from one node to another, and all those nodes need to be able to trust where the messages or the data is coming from. So they need to be able to mutually authenticate each other. And in 5G, 5G is building on top of the security foundations laid by 4G, and it enhances the capabilities on top of 4G. For example, we talked about trust or the mutual authentication. It provides confidentiality. Any user data that is sent from the device to the network over the air and through the operator's network is encrypted so that eavesdropping is not possible. It provides privacy. The user identity is protected. So, for example, the IMSI is encrypted. It's never sent over the air, but if it is sent, it is encrypted. The TIMSIs are being sent much more frequently so that you cannot track the user. So these are enhancements that did not exist in 4G. Data is integrity protected, and on the network side, if there is any security breaches, they're contained, they're isolated and contained within certain network functions. You have this concept of network slices in 5G to address different verticals. And each of you need isolation between these verticals so that if there is a breach in one of the slices, it doesn't leak over into other slices. And resilience, like if you have a node that goes down, can you still transfer data? All of this is central, and all of this is integral to the 5G design. So if you combine this with any end-to-end security that an automaker provides in terms of security at the application level or the service level, then you have a car that is very safe and highly reliable next generation connected vehicle.
So we've been hearing a lot about the technology and the way that affects users. I'd like to talk a little bit about the car itself. So this question is for Hajong. Hajong, can you talk to us about how there's maybe changes in the antenna system in the car with respect to 5G and how that's evolved?
Sure. But actually, the large number of antennas are required for 5G telematics. And this is even more the 5G DSDA telematics, because that there are 2 SIM cards and 2 different RF passes. This is very challenging to integrate this large number of antennas in the very small, shark fin antennas. Actually, also that the antennas mounted on the roof deliver the car OEMs the improved system performance and cost saving by removing cables and combiners. That this enables the reduce the distance between the telematics and the antennas. And compared to the conventional shark fin antennas, recently the new type of antenna is being developed to have a flat roof shape by removing the shark fin antenna. It has this new type antenna has many antenna elements in the wider area for not only for mobile communications but also GNSS and other services for FM or any other services. However, there are some technical challenges need to be overcome. For example, antenna performance is impacted really by the vehicle body, and also because that these antennas and telematics is mounted under near the roof, there are the ambient temperature for this roof. The ambient temperature for the roof environment is very high, and so we need to investigate the thermal management for this new type of environment.
And if I may add, I think on V2X you have additional challenges, like you need to be able to see on all the sides, and usually the roofs are sloped, and if you have an antenna on the back, you're not able to see in the front. So you may need an antenna in the front and the back. And what do you do with convertibles? Challenges.
Yeah, there's certainly no short of technical challenges. I think there's also some changes that we're seeing inside the systems of the car on the architecture of the vehicle itself. Norbert, could you help take us through some of the evolution that we're seeing in the vehicle beyond just the antenna?
Yeah, thanks, Sherry. I'm happy to answer that. If you look to a classical traditional car today, it's very much consists in its architecture from distributed processors and sensor data collection. And 5G is a lot about data and sensor data. So a classical vehicle has its own processor for the engine, for the injection system, for the headlights, for the wipers, for the infotainment system, for the seat adjustment, the climatic environment system. So depending where the OEM has been sourcing certain subsystems, the processor came with it, right? And then there's a central computer who again controls certain subsystems. And once a world-leading car maker now has disassembled one of the world-leading new electric vehicles, and they have found a complete new architecture in a sense that the processor capability is very much centralized into one core central processor that gigantically controls all the sensor data and all the functions of the car from one central point, which is an architectural revolution, I would say, to what's in place today. And the data, there's public reports to that. And the data feedback says that those traditional car makers are 5 to 6 years away from those new telematic processor structures in a ground-up built electric vehicle. So this is a massive change if you think about it, right? Because now all the data correlation to be done in one processor, or you want to change certain subsystems of the car, yeah, you have to go to your supplier one. You want to change another subsystem, go to supplier two, and so on and so on. And the new vehicle architecture says, it's okay, I can change my subsystem suppliers. There's new e-vehicle manufacturers also, but do not produce electric seats, but they control the electric seats centrally, right? And this is a total architectural change, which for classical OEMs needs a couple of years to catch up to. But that's to be the architecture of the future.
There's certainly a lot of new technology, a lot of forethought is being put into 5G so that we build from this new technology up into the use cases that 5G enables, and new experiences, new types of economy, sharing vehicles, autonomy, and so on. I'm very excited about 5G coming to the car. I think we'll start to see 5G rolling out in the coming months. I think we'll start to see some global deployments in certain markets. So I'm very excited about it. So thank you, everyone. I want to thank our panelists today for sharing their thoughts on how 5G is changing the landscape in the car. I want to thank our attendees for joining. I hope you found it informative in this panel discussion on how 5G is advancing us to the next generation of mobility. And I hope you find the rest of the automotive showcase put on today by Qualcomm is informative and brings new ideas to your perspective. Thanks again.